Can you hear me? Hello, students.
Yes, sir.
Okay. So, in the syllabus of Design of Structures 4, the syllabus is quite big, and therefore we have to emphasize on the more important topics. And I'll be starting with press steel tank. That will cover actually the analysis and design of steel frames, much of which you know, and also seismic analysis of water retaining structures. And I am showing you the general arrangement of press steel tanks. You will understand what is the actual arrangement. I request you to record the class and also to take down notes. This is the code IS 804 1967. This is on press steel tanks. And I will explain you what is meant by press steel tanks. See, in press steel tanks, you have a steel tank supported on stagings, and this steel tank may be placed at a height of say 10 meter, 12 meter, and 15 meter, etc., depending on the requirement of the water head that is required at a particular location. You know that any water tank which is placed within a community, there the height of the water tank depends on the distance up to which the tank is supposed to supply the water. Now the preliminaries of press steel tank are excellently given in a book by Arjo and Ajmani, ARYA, Arjo and Ajmani. That is a very good book in which the fundamentals of steel tanks are given, press steel tanks. I would like to give you a picture of uh, the total arrangement, how the press steel tank is supported. Just give me some time. I'm sending you in your WhatsApp group. Please see the image which has been sent in the WhatsApp group. Are you seeing that? Hello?
Sir, we didn't receive any message in the WhatsApp group.
No, I forgot I have. Oh, it is going. It is going. The net is quite slow. Just wait. It is going. The net is extremely slow. It will go, but in the meantime, I want to show you. I'm putting my camera on. Can you see me?
Yes, sir.
Are you able to see this? This page?
Yes, sir. Yes, sir.
You have seen the press steel tanks being supported on steel frames.
So can you put it a little up?
Oh, it has been delivered. It has been delivered. Please see. And see this one also. Are you able to see it?
Yes, sir.
Okay. This is the book, Design of Steel Structures by R.K. Rajwani. Okay. Have you got the figure? In your WhatsApp group, have you got the figure?
Yes, sir.
Okay. So these press steel tanks are placed on steel stagings. And see, why we emphasize, and when I taught the other subjects of design, why I emphasized on the fundamentals. If you have your fundamentals clear, then you can design any structure, provided you can clearly understand that which element is acting as a beam, which is acting as a column, which member is acting as a beam column, like that. And of course, you have to have a clear idea about the analysis of the structure. Because until unless you do the analysis properly, if you miss out any load or load combination, then your design will be wrong. Now see, if you see this press steel tank, all of these panels, they are normally 1.25 meter into 1.25 meter. Okay, normally 1.5 meter across 1.5 meter, that is also possible, but 1.25 meter into 1.25 meter panel, that is most common. Okay. Now these particular sheets, they have an edge which is either rectangular bent or they are bent in some other shapes, which I will show you. And they are bolted with each other so that they can be assembled quickly and they can be deassembled quickly. Let me see. Yeah. Yes. These are how the members are connected. This is the way how they are connected. These are the plates which are bent at the end. This is a single sheet. Okay, this is a single sheet. They are folded at the end. They can be hot pressed. They can be cold pressed as well. These thin sheets, 2.5 millimeter, 3 millimeter, at most 4 millimeter, 4.5 millimeter, not more than that. They can be bent to form the flanges. These are the flanges. They can be twisted, cold twisted, or they may be hot rolled. And these particular members are connected by bolts, and within the plates you have a sort of plastic material, an elastomeric material, which is leak proof. Now press steel tanks, they have a very unique feature. You know that in steel structures, normally, since steel structures are lightweight structures of the lateral forces, normally wind force governs the design in steel structures. But in press steel tanks, we have an exception. In press steel tank, you have a heavy weight acting at the top, the water load and all, and therefore for press steel tanks, in most of the cases, seismic force becomes the criteria among the lateral forces. So that you should keep in mind. If you ever asked in a viva that in steel structures, is it necessary that always lateral forces, among lateral forces, wind is the criteria? They will answer no, sir. In some exceptional cases, seismic can also become the criteria. That is the case of press steel tank. Now, these press steel tanks, the tank portion itself, although the design is given in some books of steel design, But these are basically, see, in civil engineering language, we call it as bought out items. Bought out items, like crane girders. When I taught you the factory shed, I taught you about the design of gantry girder. The crane girder is of course designed by a structural engineer, but since cranes are supplied by mechanical engineering firms, they do it designed by any structural engineer. But those cranes are normally sold in fixed spans and in for fixed weights, lifting weight, lifting load. Similar example is lifts. When you install a lift in any apartment house or any institutional building, the lift vendor gives you the clear dimension of the lift shaft. Why does he do so? Because the lifts, they are bought out items for civil engineers and structural engineers, and the lifts are available in standard sizes and shapes, which are fabricated by lift vendors, and therefore we do not have much to do in it. Now, see, press steel tanks, how to design press steel tanks, that is important. But since in most of the cases they are bought out items, I will not go into it. I will go into the real arrangement of press steel tanks. As I told you that you have the different plates which are normally of dimension 1.25 millimeter into 1.25 meter into 1.25 meter. They can be hot rolled or they may be cold rolled to give the shapes, and the flanges are bolted together, and in between the plates elastomeric packing is there, whether there is no leakage or there is minimum leakage. That is something which is important. And the bolt, since the plates are quite thin and all the bolts are normally provided in a single line, so the plates cannot take any bending. And since they cannot take any bending, you have to provide diagonal stays, and this inclined stays, sometimes horizontal stays are also provided. These stays are provided at all the joints so that each panel will undergo bending, but the joint will not undergo any bending. I'm repeating, you have hydrostatic pressure of the steel plate, and therefore the steel plate will definitely undergo bending, but the bending of the steel plate will be within the lines of connections and as a simply supported plate. Okay, so that is important. So this is the normal arrangement, these steel tanks, press steel tanks, they are supported on beams running in two directions. In the smaller direction and in the larger direction, we can call them as X direction and Y direction. The beams may be only peripheral. The beams may be just like building frames, peripheral and internal. And sometimes it may so happen that the beams are not along the periphery. Say, along this line you have a beam, and along this line you have a beam. Along this line you have a beam, and along this line you have a beam. Means all the beams are uh, simply supported beams with overhangs. This is because the overhanging part will have hogging moment, and that hogging moment will partially neutralize the sagging moment in the simply supported portion, and therefore the design becomes economical. So I'm repeating once again, this is like a building frame. You have the stringer beams here. I mean, I'm sorry. Since this particular press steel tank floor, these connections, they cannot take any bending. Therefore, you have some small depth beams at along each of these lines that you have, but those are not the main beams. The main beams, which will transfer the load to the columns, they will be either peripheral or at along all grid lines, or they may be along the last but one grid lines, so that the beams are deliberately kept a bit cantilever so that the negative moment partially balances the positive sagging moment. That is done in many cases. And if you really look at the images that I have sent, you will see that you have cantilever projections. Okay. Now, if you really look at this code, IS 804, they have actually given some charts where the capacity of the tank is given and the plate dimensions are also given and the plate thickness is also given. That means these press steel tanks are already designed. I am repeating. This is 1.25 meter is the depth of water. Plate thickness is 5 millimeter all through, means the top plates, the bottom plates, and the side plates. And you have the dimensions of the tanks. You will see that all the dimensions are multiples of 1.25 meter, and the capacity is given there, and the approximate empty weight of the steel tank is also given there. Okay. So I will request you to write a problem. I request you to write a problem of a rectangular press steel tank whose dimensions, the tank dimensions, length is 7.5 meter, the width is 6.5 meter, and the depth is 2.5 meter, and it is at an approximate height of 9 meter above the ground level, means the tank bottom. Have you copied? The length of the tank is 7.5 meter. Vicky, হ্যাঁ কিন্তু আজকে সময় হবে না বুঝছো কিন্তু সময় নেক্সট উইক ছাড়া, হ্যাঁ নেক্সট উইক প্লিজ, হ্যাঁ এই সপ্তাহে ভীষণ চাপ, ঠিক আছে? ওকে, নেক্সট উইকে মানডে ফোন করো প্লিজ এই সময়। থ্যাংক ইউ। ওকে ওকে। সো have you all copied the data? Hello?
Yes, sir.
The length is 7.5 meter. The width is 6.25 meter. The height is 2.5 meter of the tank. And the height of the tank bottom from the GL is 9 meter. Now in any tank, you have to give a freeboard. 2.5 meter is the height of the tank, means maybe water is up to 2.2 meter and 300 mm is freeboard. But when you actually do the calculations for seismic and all, you can take the total height as 2.5 meter. You can take the total height to be of water, filled up with water, and you can get conservative results. Although in practice, up to 50 mm to 300 mm freeboard is always kept and maintained. Now you have to arrange for a frame arrangement. I will, you tell me if you have 7.5 meter here, so you will be having 6 into 1.25 na? To 7.5. So you have to place 6 plates. So there are 7 grid lines in one direction and 6 grid lines along another direction. Am I correct? Am I correct? Hello?
Yes, sir.
7.5 meter means 1.25 meter into 6, and 6.25 meter is 1.25 meter into 5. So you have 6 grid lines in one direction and you have 7 grid lines along the other direction. Now I will request you to put 4 columns, not at the ends. If you Just put the 4 columns here. Put a column here. Put a column there. And symmetrically in this side. So put 4 columns, okay? Now, if you want to calculate, please take your pen and calculators and all. Have you taken? Have you taken your pens and calculators? Hello?
Yes, sir.
Okay. Please take SP61 with you, the section handbook you take with you. Section handbook, you have it with you? You take that. Now tell me, what is going to be the going to be the weight of the tank with the liquid? Here, I'm taking this thing. Huh? Am I clear? Is it visible? I will share the code with you.
Yes, sir, visible.
বুঝতে পারছি তোমরা 7.5 into 6.25. Okay. বলুন। মর্নিং। গেলে ফোন করবেন, পাঠিয়ে দেবো। গেলেই ফোন করবেন। So the capacity of the tank is 117 MQ. 117,000 liters, so 117 MQ. So বলুন, হ্যাঁ, ধরুন ধরুন। না, কিছু আসেনি আমার কাছে। মেসেজ তো না, আসেনি কিছু। জাস্ট ওয়ান। গেছে, ধরুন ধরুন। কোনটা বলবো? ধরুন ধরুন। 807448। হ্যাঁ হ্যাঁ, ঠিক আছে। So please write down the weight of the empty tank. Weight of the empty tank is 7.7 ton, and and weight of water is 117 ton. Am I correct? Because density of water is 1 ton per meter cube. So 117 ton is the weight of water, 7.7 is the weight of empty tank. Now the weight of empty tank matters because you have to do two analyses, one in empty condition and another is in full water condition. Because sometimes under full water condition compression will be maximum, but since these are lanky structures with mass lumped at the top, sometimes uplift comes in the foundation. and columns are sometimes subjected to tension. And therefore, you never know that under empty condition and wind load acting on that, and under tank full condition with seismic load acting on that, in which case the tension is maximum in the column. Have you understood? The compression will be obviously be maximum under tank full condition, dead load plus water load plus seismic load. That will be obviously the columns will be under maximum compression, but maximum tension we do not know. Maybe under seismic case with tank full condition it may have maximum tension, or tank empty under wind load condition. Dead load of course will be there. Dead load plus wind load condition, it may undergo reverse compression. So we never know. Now you have to approximately find out but what is the center to center distance between columns? 4.75 in one direction and 5 meters in the other direction. Am I clear? Since you have provided columns in the last part 1 grades, therefore along x direction, if you take the tank dimension to be 7.5 meter, then the center to center distance between columns in the x direction is 7.5 minus twice 1.25. That is 5 meter. And in the y direction, the center to center distance between columns will be 6.25 minus twice into 1.25, that is 4.75 meter. Am I correct? বেশি বুঝতে পারছো?
হ্যাঁ স্যার।
Okay. Now we have to get the the empty weight of the tank is 7.7 ton, and you multiply that by approximately 10% to take care of the bolts, to take care of the elastomeric packings, and to take care of the stays and the non-primary beams. Between the columns, primary beams will run, but between the primary beams, you will have secondary beams as well. So you please add 10%. So 7.7 ton into 1.1. So please see what it comes to. 7.7 to 1.1. So 8.47 ton is the weight of the tank. Empty weight of the tank. Now, if you want to get an approximate idea of of the columns, what you can do is, see, we will calculate definitely the seismic force, but for the time being, since you have done many building design and all, you have an idea that 5 to 8% of the weight of the structure is normally the seismic force. You have an idea, no? So,
Yes, sir.
তাই জানো তো তোমরা এরকম?
হ্যাঁ স্যার।
So what you can do is, if you assume 6%, so what is the total weight of the tank, including the contents? You tell me. 117 plus 117 plus 7.7 into 1.1, তাই তো?
হ্যাঁ স্যার।
কত এলো total weight of the tank with water?
125.47.
Yes. And if you take 6% of that as the horizontal force, approximately, so do you get 7.5 ton?
Yes, sir.
So 7.5 ton will be the approximate lateral load, okay? Approximate. Now it will be acting at the CG of the tank. So 9 meter is the height plus 2.5 meter by 2, right? So 9 meter is the height of the staging, and center of the tank is 2.5 meters, so middle of that. So 2.5 by 2, 1.25. So it is 10.25. So 10.25 into 7.52. 77.16 ton meter is the seismic moment. Do you admit?
Yes, sir.
Okay. Others, please tell me, do you admit?
Yes, sir.
Okay. Now in the shorter direction, in the y direction, the lever arm is less. You please recollect when I taught you gantry column. I told how use initial sections to divide the moment by the distance between the columns. Did I not tell you? So 4.75 meter is the center to center distance between the column lines in the y direction. Do you admit? Hello? In one direction, the center to center distance between the columns are 5 meter. In the other direction is 4.75. Agree করছো?
হ্যাঁ স্যার
So if you divide this moment divided by 4.75, then you get 16.24 ton. Okay? পাচ্ছ তো বাবা?
Yes, sir.
16.24 ton is the compression taken by two columns on one side. So please divide it by 2. 8.12 is the maximum seismic compression on one leg. তোমরা প্লিজ আমাকে বলো তোমরা বুঝেছো কি বোঝোনি? Please tell me. This is exactly how we initially chose the components of the compound gantry column. We divided the dead load by 2 and we divided the moment by the lever arm. Here we will divide the dead load by 4. I'm sorry, dead load plus water load. We'll divide that by 4 and to that we will add this 8.12 value because we have two columns in the tension side and two columns in the compression side. বুঝেছো কি বোঝেনি আমাকে বলো তোমরা?
Yes,
Hello.
sir.
Okay. Now you tell me what was the total dead load plus water load value? 125.47. Hello.
Sir, it was 125.
হ্যাঁ স্যার
হ্যাঁ এটা বলো সেটা বাবা, নইলে হবে কি করে? তোমরা 4th ইয়ার উঠে গেছে, প্রজেক্ট করছো, তুমিও করবে আমিও করবো, আমি গাইড করবো তুমি শিখবে। আর শোনো তোমাদের থিওরি ক্লাসেও যা পরশুদিন সেশন ক্লাসে একই জিনিস করাবো। তোমাদের যেমন পড়েছিলাম আমি 4th ইয়ার ফার্স্ট সেমে যে থিওরিও যা সেশনালও তাই, এটাও তাই। যেটা থিওরিতে পড়াবো সেটাই প্রজেক্ট করবে যাতে কনসেপ্টটা ক্লিয়ার হয়। তাহলে 125/47 যে ডেড লোড প্লাস ওয়াটার লোড এটা কটা কলমে যাবে?
4টে
রাইট, ডিভাইড দ্যাট বাই 4. Divide that by 4 and add 8.12 to that.
So 39.5 approximately.
বলো।
So 39.5.
Okay, so 39.5 ton is the worst compression in each column. Okay. And I told you in previous classes also that see compression, when you talk of compression, you assume the sigma AC value as 100 MPa. Did I not tell you? বলেছিলাম তো।
Yes, sir.
তাহলে এইটা কত? 39 টন। 39 টন মানে কত? 390 কিলো নিউটন। হ্যাঁ গো, 390 কিলো নিউটন তো।
Yes, sir.
So 390 into 1000 is Newton divided by 100. So do you need 3900 mm square area? Do you need 3900 mm square of area? তাই তো 39 centimeter square area লাগবে তো নাকি? আমি ঠিক বললাম?
Yes, sir.
Yes, sir.
Approximately 900.
বলো, you ask me any question. বলো। Any question do you have?
No, sir.
Okay. So if you go to your section book, SP6 part, you can pick up ISMB 300. You can pick up ISMB 250 also, whose area is 4755 mm square. তোমার কত mm square লাগবে বলো?
So 3900.
Okay. তোমার 39 mm square তো? আরেকটু বাড়াও because these are important structures. ISMB 250 না করে আমি ISMB 300 বললাম, তাই না? ISMB 300 has an area of 5626 mm square. কেমন? ঠিক আছে?
Yes, sir.
তাহলে এটা তুমি করলে তোমার 4টে কলাম তোমার হয়ে গেল। এবার যখন তুমি এটা করলে, so you provide bracings. You have 9 meter, okay? So you provide horizontal bracings at every 3 meter Let that be ISMB 250. Let that be ISMB 250. And you can provide diagonal bracings, which may be also ISMB 250. বলো, বুঝতে অসুবিধা হয়েছে না হয়নি বলো? তুমি হরাইজন্টাল ব্রেসিং, ডায়াগোনাল ব্রেসিং দুটোই দিতে পারো। আমি সেটাই করি, তাতে আমার সুবিধা হয়। এবং তুমি একটু মনে করে দেখো, তুমি যে ট্রাস ডিজাইন করেছো আগের সেমিস্টারে, the the side rails were horizontal bracings and you had diagonal column bracings. মিল পাচ্ছ না পাচ্ছ না? বলো, মিল পাচ্ছ না পাচ্ছ না? হ্যালো, can you hear me? Hello.
Yes, sir.
Okay. So what we can do is, তাহলে আমার প্রিলিমিনারি ডাইমেনশনিং হয়ে গেল, তাই তো?
Yes,
আমার
sir.
ডাইমেনশনিং হয়ে গেল। এইবার আমি এটা মিটার অ্যানালাইসিস করবো, সিসমিক লোড অ্যানালাইসিস করে আমি এটা ইয়েগুলো বার করবো, ডিজাইন করবো, ফ্রেমিংটা, ফ্রেমিংটাকে বেস কানেকশনকে সব কিছু। তোমরা উইন্ডো অ্যানালাইসিস করে আনবে থার্সডেতে, আর আমি সিসমিক অ্যানালাইসিসটা তোমাকে পড়াবো। কি কি কোড লাগছে আমি তোমাকে একটু ফরওয়ার্ড করে দিচ্ছি। বলো ঋষি।
হ্যাঁ স্যার।
ঋষি, তুমি অ্যাটেন্ডেন্সটা রাখতে পারবে তো?
দেখে নেবো স্যার, অসুবিধা হবে।
স্যার,
হ্যাঁ বল বল।
স্যার ব্রেসিংগুলোকে আলাদা করে ডিজাইন করতে হবে?
নিশ্চয়ই ডিজাইন করতে হবে, আমি তোমাদের আগে শিখিয়ে দিয়েছি, এখানে আবার শিখিয়ে দেবো।
ওকে স্যার।
তুমি মনে করে দেখো, কলম রেসিং আমি পড়াইনি আগে?
হ্যাঁ স্যার, ঠিক
এই
আছে।
এই ফান্ডামেন্টালটা কি ক্লিয়ার করবে সবসময়, যে মানে জিনিসগুলো কিন্তু তোমরা টুকরো টুকরো করে শিখেছো। যখন তুমি ইন্ডাস্ট্রিতে যাবে, যখন তোমাকে বিভিন্ন স্ট্রাকচার দেবে, অবশ্যই তার অ্যানালিসিসটা আলাদা, কিন্তু ডিজাইন কিন্তু আমরা যাদবপুরে তোমাদের সব শিখিয়ে দিয়েছি। তোমাদের টেনশন মেম্বার শিখিয়ে দিয়েছি, কম্প্রেশন মেম্বার শিখিয়ে দিয়েছি, বিম শেখানো হয়েছে, লো শিয়ার বিম শেখানো হয়েছে, হাই শিয়ার বিম শেখানো হয়েছে। হ্যাঁ, তোমাদের কলম শেখানো হয়েছে, তোমাদের বিম কলম শেখানো হয়েছে, প্লেট গার্ডার শেখানো হয়েছে, তার স্টিফেনার শেখানো হয়েছে। অর্থাৎ সবকিছু টুকরো টুকরো করে শিখিয়ে দেওয়া হয়েছে। Now you have to understand that which structural element is behaving like what. Okay? তাহলে আমি এখন বেরোচ্ছি, তোমাদের সঙ্গে থার্সডে দেখা হবে। কেকেএম স্যার লিঙ্ক পাঠাবেন, আমরা ওটাতে মিট করবো, কেমন? তোমাদের আইএস 804 দিয়ে দিলাম, 1893 পার্ট 2 দিয়ে দিলাম। এবং তোমরা যদি যদি তোমরা আরজি আজমানির বইটা ডাউনলোড করতে পারো, আমি তোমাদের পুরোটাই করিয়ে দেবো, কিন্তু আরজি আজমানির বইটা স্টিল ডিজাইনের কেনার দরকার নেই, বিকজ ইট ইজ অ্যাকর্ডিং টু দ্য ওল্ড কোড অন আইএস 1893 1984. Don't immediately purchase it. তুমি যদি এটা কিনে নাও, ডাউনলোড করতে পারো, ভালো। ঠিক আছে, আমাদের ক্লাসটা থেকে বেরোই। আমি তোমাদের গেটের আগে এক সপ্তাহ তোমাদের ছেড়ে দেবো, তার আগে তোমরা ক্লাসগুলো করে নেবে। হ্যাঁ, রাখছি। ওকে।
অর্ঘ,
ভাই রেকর্ড করেছিস তো? আর গো,
শোন শোন অর্ঘ,
তুই বর্ষা।
একটা অ্যাটেন্ডেন্স